Hey guys. It's been it's been a few days since I've last done a recording, and today, as you can see in the title, I'm going to teach you a unique way of doing division. So we're not going to be doing standard long division, but I'm going to teach you a division that works off of timesing a number by 2. So mostly about doubling, which should be fun. It means you don't have to memorize every single lookup table of that number you're working with. All you have to know is how to double it. So let's go ahead and do a problem. So I'm going to do 7 divided by 320. So how do I even approach this problem? Well, since we're going to be going for remainders, I'm going to go ahead and use only integers over here to do our doubling. If you wanted to get decimal place remainders, you need to start halving along the way, but we're not going to do that because then your answer will actually be worse. So here's what we're going to do first. First, we're going to double 7 until we find a number that goes over that one. So first we have 7, 14, and then we just double 14 to get 28. And then we double 28 to get 56, and then 112, and then we double that to get 224, and if I doubled this again, the number would go over 320, so it's going to be completely useless. So now here's what we're going to do. Now I'm going to go ahead and label the side here. So we've got a 1, 2, and then right here we've got a 4, 8, 16, 32. You see where we're going with this problem already? This is sort of like binary in a way, but I'm representing it in decimals so we could try out this technique of division. So the first number we can fit into this as groups of, or as multiples of 2 is 224, so I'm going to do 224, if I can write it, of course. So we'll do 224, and then what we're going to do is we're going to put a plus sign there, and, oh, I actually messed up. Nope, scratch it, scratch that, don't do that. That was terrible. No, we want to put 32 in there because we're doing groups of multiples of 2, rather. So let's put 32 up here. Forgive me. Now we're going to put 224 right here. I'm so sorry. Now we're going to subtract. So, well, we're going to have to borrow. So I'm going to borrow this 2 for now. And then I'm just going to put 6. And then I'm going to borrow the 3 so that I can get an 11 rather, which will give me a 9 when we do 11 minus 2. And then if I do 2 minus 2, I just get 0. So far our remainder is 96. And now, since we already have our lookup table, we just go ahead and look up what will be just under 96. Well, it looks like our number 56 is just under 96, so that's what we're going to do. We're going to add the 8 up here. And now I'm going to go ahead and subtract 56. So as you can see, we've already gotten rid of all the mental arithmetic. We've done it all. All we have to do is just select which one's just under that number and just subtract. It's pretty easy. So we can put 0 and 4, so we have 40. And now we're going to see what's just under that. Well, it looks like the number 28 is going to just be under that. So now I'm going to put 20. I'm not going to put 28. I'm going to be putting 4. So we've got 8. Now we've got 4. And now I'm going to subtract this by 28. And now we're going to have to borrow. So I'm going to borrow a 1 from there to complete the 10. And then I could just do 2 and 1. So we've got a 12. And guess what? We just check which number is going to be next. So the next number, it's not 14. It's going to be 7. So therefore, we need to add 1 up here. And we're going to go ahead and subtract 7. And 12 minus 7 is 5. So the answer is the sum of this, and the remainder is 5. So let's go ahead and sum this. So this is 32 plus 8, which is 40. and this would be 44, 45. So our answer is 45, remainder 5. And here's what you could do with a calculator. All you need to do is do 45 times 7 plus 5. So 45, if I could do it. Looks like I have to do some real quick. Okay. So yeah, we're going to do 45 times 7 plus 5. And our answer is 320. So indeed, 45 remainder 5 is the correct result. So let's go ahead and do another problem using this new trick that I'm showing you. Or rather, it's kind of old because this is how binary division's done. Although I'm representing it in decimal so we could see how it works in theory, right? I think that's cool. I'll go into binary division later because I plan to make a tutorial series on this kind of stuff soon, so that should be fun. Alright, so let's do another problem. Let's do something ridiculous. I'll just do 5 times 972. A nice big number. And 5 is such an easy number to double, so let's go ahead and start doing that. So we start with 5, double that's 10, double that's 20, double that's 40. So it kind of exponentially just helps us out here, which is great. So double 40 is 80, and then 160, and then 320, and then 640. And I cannot double this or else it'll go over 972, so we're not going to do that. And now I'm going to put my doubling representation, so that's just 1 time, 2, 4, 8, 16, 32, 64, 128. And yeah. And I mean, believe it or not, if you work a lot in binary, you can actually just remember these numbers off of your head, off the top of your head. So you could just like double this mentally as you go along with your problem, but it would take longer. So making a little table here at the beginning is perfect because all the work's done for you. So, all right, so here's something we already have as a given. So essentially 640 is just under 972. And that means 5 times 120 is 640. So what we're going to do is we're going to put 128 up here. And then we're going to put our plus sign. And then we're going to just subtract 640 with my terrible looking 6, of course, because that's how it's done. So we had 2, 3, 3. So that's our 332. And now we just go to our lookup table and we just check what's just under that. And it looks like our number 320 is just under that, which means we need to do 64 times. And then I am going to subtract 320 from this. And it's pretty easy. What we could do is we could just focus on this group. So let's do 33 minus 32. In our case, that's just 1, so we get 12 as our remaining answer. Okay, now let's just use our lookup table. I don't know, it could just be 10. Yes, because it just so happens that 10 fits just under 12, and we just have to add 2. So yep, adding that. And now we are going to subtract 10. Which gives me 2. And we're done because there's nothing left on the lookup table that I could use to do this anymore. So we're kind of stuck. So it's going to be this result, R2. So let's go ahead and just sum up that result. So 128 plus 64 plus 2 is 194. So it's 194 R2. And now we're going to just do the same exact test. We're going to take 194 times it by 5, and add 2, and we get 972 back, and that is correct. So the reason why I showed you this situation is because I wanted to show you if we cannot use the table anymore. In that case, you just have your remainder left. So I hope this helps. And before I go, I'm going to go ahead and show you how you could also get decimal places to an approximate result, of course. So instead of doing this, you want to ask yourself how many decimal places you want to predict. In this case, 4 is a good amount. So what we're going to do is we're just going to do halving of this number. So if we do this, it's just going to be 5 over 2, and then it's going to be 5 over 4, 5 over 8, until we get to that 5 over 16. So this would help you get your decimal places up to a certain amount, which is kind of cool because that means you don't have to be so predictive. You can actually give yourself the exact amount of approximation you need. So yeah, again, I hope this helped, and maybe in the future we should start doing some computational stuff for fun, because it would actually be cool seeing this being implemented in some way, you know?